Okay, we're ready to start week 11. And the first homework assignment is actually like an extension of use substitution from the end of week 10. And it's actually just another way. And so I'm going to show you on problems 2 and 3 how we're just going to kind of take it a little different. This assignment is talking about using new bounds to find your limit rather than switching back to x and using the old bounds. So on a couple of the questions, it'll simply say, what are the new bounds? So if these were the old bounds and this is what you're substituting, what are the new bounds? And so that's a pretty simple process. When I rewrite this with a new integral and with my u in it instead of my x, these wouldn't be my numbers anymore because these are my values in x, but now I need my values in u. And so that's what it's asking is, what are these new bounds? If I were to do it this way that they're having you try. And that's an easy thing. You just plug them in, okay? So if I plug in pi over 4 to cosine, then that would be root 2 over 2. And so that would be your new upper bound. And if I plug pi into cosine, that would be -1. So that would be your lower bound. So again, you're just plugging these numbers into this new substitution. So one of them would be cosine of pi over 4, and one of them would be cosine of pi. Cosine of pi over 4 is root 2 over 2, and cosine of pi is -1. And so that's a pretty easy thing, just to find those new bounds. Okay, so some of them just ask for that. That's pretty simple. Now, this problem looks exactly how we did it last week. And you could do this exactly how you did it last week, make no changes, and you would get the right answer. I'm just going to show you kind of a different way. And it only changes at the very end. And really, you can just decide if you want to do it this way or just keep doing it how you're doing it last week. So just like last week, we're going to figure out that u value. And it's going to come from that more complicated part of that power. So that's going to be 3x cubed plus 1. And then we're still going to take the derivative. And so that would be 9x squared dx. And then the same thing, you've still got to make those match. So to make a 9x squared match a 2x squared, we're going to have to multiply by 2/9. So I'm going to multiply 2/9 du equals 2x squared dx. And now we're ready because we have a 2x squared, we have a dx, and we have our u to the 5th. So now I can rewrite this as 2/9 usually goes on the outside. And then 2x squared dx is du, so that's just u to the 5th du. Pretty simple, right? And then we've got to do our derivative. And so that would be 2/9 times u to the 6th over 6. And if I want to rewrite that, that's a 1/27 u to the 6th. Okay, now this is where things change. Last week, you would have then substituted this back in and used these original numbers. But today, what they're encouraging you to do, and you don't have to, it comes out the exact same answer, so I don't care, but they just say leave it. But find your new numbers, because if you're going to leave the u in there, then you can't use the x numbers. We've got to do what we did up there and find our new numbers. And so just find a little spot, and we're just going to plug 0 into here. So that would be 3 times 0 cubed is 0 plus 1 is 1. And then plug in -1. So -1 cubed is -1. So -3 plus 1 is -2. See, that does not take very long. And now I can just find my answer rather than substituting this back in, just doing it this way. And it comes out the same. I'll show you in a second because I actually did it both ways. So then that would be 1/27 times 1 to the 6th minus 1/27 times negative 2 to the 6th, which is 1/27th, minus 2 to the 6th is 64 over 27, which is negative 63 over 27, and that would reduce to negative 7/3. Okay, lovely answer. Now, without taking all the time away, let me show you what I did just so that I could check it myself. Okay, so I did it the way we did it last week. So right here, when I got to that point, I substituted that original u back in, and I used the original numbers. And I got the exact same thing. So it's kind of like a little math magic there, right? You've got to just decide this week which way you like better. Do you like substituting the u back or the x's back in and using the old numbers? Or do you like what they're doing? Do you like just leaving it with the u, but finding your new numbers? Totally your choice. I don't care, because it's going to come out the same. But this kind of is nice. I don't know. Okay, and then same thing with this. Trig functions. We did trig functions last week, so no big deal. But, you know, their challenge to you this week is to try it this new way, right? So I'm going to focus right here on this tangent for my u. So u equals tangent of 3x squared. And the reason I did that is because the derivative of tangent is secant squared. So it's going to take care of that for me. So du equals secant squared 3x squared. And then power rule, derivative of 3x squared is 6x. And I'm going to look up here, and I need a negative 2x. So to get a negative 2x out of a positive 6x, I need to divide by negative 3. So this is going to be negative 1/3 du equals, I'm going to move that forward, negative 2x secant squared 3x squared dx. Forgot the dx on that. Okay, so that's kind of off the paper. Let me show you that for a minute. And then notice that negative 2x is going to take care of that negative 2x. And then secant squared 3x squared dx. So all of that's going to turn into that negative 1/3 du. And then this is just going to be u to the 4th. Okay, u to the 4th. Okay, so we're going to rewrite this with a negative 1/3 and then the integral of u to the 4th du. Much simpler. Okay, and then integral, so that would be negative 1/3 times u to the 5th over 5, which I could rewrite as negative 1/15 u to the 5th. Okay, now this is where you got a choice to make. Do you want to plug this back in and use these numbers? Or do you want to leave it the way it is and find new numbers? Well, because I'm the teacher, I'm going to do it the way they want us to do it. So I'm going to find the new numbers, and I'm just going to leave it with that u there. Okay, so to find the new numbers, I've got to plug root pi over 9 into this. Okay, well, root pi over 9 squared is just pi over 9, times 3 is pi over 3. And tangent of pi over 3 is just root 3. Root 3. And then I'm going to plug in a root pi over 12. So come over here. If you take a square root of pi over 12, that's just pi over 12. Times 3 is pi over 4. And the tangent of pi over 4 is just 1. 1. Root 3 and 1. That's kind of nice, isn't it? So then, easier numbers, we didn't have to put, all this back in there. I don't know, it's kind of cool to me. So then to evaluate it, I would have negative 1/15 times root 3 to the 5th minus negative 1/15 times 1 to the 5th. And then if you probably could type it in just like that, but this one isn't too bad to simplify. I would just write this as one fraction. So I would write it as root 3 to the 5th over 15 negative. And then this is just 1. So negative times negative would just be plus 1/15. And that's a good answer. I kind of like just finding the new numbers and not substituting this back in. But honestly, it probably takes about the same amount of time. So whichever way you like to do it better, last week where you substitute it back, or this week where you don't, you get the same answer. So do what you like. And I hope that helps.